All right, so we're doing the second day of section 2.1. Okay? You gotta wait. Yeah. So section 2.1, part B, polynomial functions, the definition, the degree, and zeros. All right, sorry about that. But we're gonna basically just talk about the definition of what it means to be a polynomial function. Okay? How to identify the degree, also the leading coefficient, and then how you find zeros. Okay, how you find solutions, answers, and stuff like that. Okay, so we're gonna do like two main things today. So let's start off with the definition first. So this is the definition of a polynomial function. So I'm going to put given a power of n. Okay, so I'm going to give you a power of n. So whatever it happens to be, it's going to be the nth power. N must be positive. Okay, so it's got to be positive. Okay, and a whole number. So in other words, it can be like x to the second, x to the third, x to the first, x to the 10th. That's okay. It cannot be x to the negative 3, because negative 3 as a power would be a negative power, and they say n has to be positive. Okay? So it cannot be a negative number. It also can't be a fraction. You can't have a power of half. Okay? So so when you have this type of definition for a polynomial function, n has to be positive, n has to be a whole number, okay? And usually the way they write it, and I wrote it earlier, looks something like this. And not that you have to memorize this, I kind of mentioned that before. It's just kind of like the general form of what they're supposed to look like, but we're never going to write anything this big, okay? Don't worry. But there's a couple things that you guys have to know about it, okay? So n, this is called the degree. Okay? The degree. The definition of degree means highest power. And then a is called the leading coefficient. So this is called the leading coefficient. Okay? Which is always in front of the highest power. So in front of the degree. So I'll kind of highlight that for us here. So the degree is n, and the leading coefficient is a. All right, so this is the definition of it. Now, they are going to ask us some questions on the homework that are pretty easy. They're very easy, but you do have to understand what a polynomial function is. So you have to know, like, okay, the power, that's like all the powers on it have to be positive. None of them can be like in fractions. There can't be like a something over x. Okay, we can't have them like in the denominators. It has to all be positive powers, and they have to be whole numbers. No fractions, like no x to the 1/3, no x to the 3/4, nothing like that. Okay, they have to be like x squared, x to the 5th, x to the 10th. Okay, that's okay. No x to the negative 5s. No x to the negative 3s. No negatives. Okay? So that's what makes it a polynomial. Again, the n term right here in the very front is called the degree. The a term is the leading coefficient. I kind of highlighted those yesterday in your notes as well. So those right there. Okay? So now that we know the definition, there's going to be some questions on your homework that they're going to ask you to tell them whether or not these are polynomials, tell them the degree, and tell them the leading coefficient. So here we go. So this is going to be example number 1. State the degree. Again, this is really easy, guys. State the degree and leading coefficient of the polynomial. Okay, if it's not a polynomial, state why. Okay, like why is it not a polynomial? So we're going to state the degree and the leading coefficient of the polynomial. Only if it's a polynomial. If it's not a polynomial, we're going to tell them, well, I can't state it because it's not one. Why? Well, the power is a fraction, or the power is negative, right? The variable is in the denominator. That can't happen, because if a variable is in the denominator, that means the power is negative. Okay? So here we go. Part A. Let's do negative 2x to the third plus 6x squared minus 9. So here's our first one. So is this a polynomial? So I'm going to look at the x's, okay? Just look at the x's or whatever variable. Do they have, and I kind of wrote that 3 kind of high. Let me bring it down a little bit. But do they have only positive powers for this one? A 3 and a 2. Those are positive powers, right? Are they fractional powers? No, they're whole numbers. So that means this is a polynomial because it has positive whole numbers as their powers for the x's, okay? So yes, it's a polynomial. I don't have to write anything about that, but I do have to check it. Now that I know it's a polynomial, what is its degree? What's the highest power that you see? What is the highest power? 3. And what is the leading coefficient? Remember, the leading coefficient is the number in front of where you found your degree. What's my leading coefficient? Negative 2. And that's it. I'm done. I don't have to do anything else. These problems, like I told you, they're simple. They're easy. You just got to check, is it a polynomial? If it is, tell me the degree, tell me the leading coefficient. Okay? Notice the leading coefficient is negative 2 because that's the number in front of the highest power, right? So it's not going to be 6 because 6 is not the highest power, right? It's not in front of the highest power, sorry. The highest power was x to the third. So the number in front of that term will be your leading coefficient. Let me give you another one like this. So you're going to have 4 of these type of problems to do, but they could look a little different, okay? So what about something like this? So I'll give you, let's say 8y squared minus 3y plus 6y to the 7th minus 2. Here's another one. Let me rewrite that. It kind of looks like a squiggly line there, right? That is a 7. All right, so is this a polynomial? So you're going to look at all your variables, y's, y's, and y's, right? Y squared, y to the first, y to the 7th. Are they all positive whole numbers? A 2, a 1, and a 7. Yeah, they are. So is this a polynomial? Yes, it is. What is the highest power? That's going to be my degree. So 7, thank you. So the degree is 7. What's my leading coefficient? 6. Thank you. And that's it. Now I'm going to show you one that doesn't work. Okay? I'm going to show you one right now that does not work. It kind of looks like it should work. So this one looks like it's okay. Because if I were to tell you what are the powers on your variables, you see 3 variables, right? There's an x squared, so that's a 2. Then there's a x to the first, right? And then you might say, well, here's another x, and it's to the first power, right? But what did I tell you? If the variable is in the denominator, what is its power? It's negative. This is a negative power. Can a polynomial have negative powers according to the definition? No. Powers have to be positive and whole numbers. Okay? So I'm just going to write, I guess I could put like 2 over x. I'm going to put right here, has a negative power, not a polynomial. Okay? So I'm going to write that it's not a polynomial, but I'm also going to tell it why. Okay? That little piece right there, that's a problem. Okay? Now, if they make you distribute, I mean, don't freak out if you see this, but you might see something like 3d plus 1, 6d minus 1. They might give you something like this. Okay? Now, from here, you can't really tell because you have to distribute it and write it all out first. Okay? So we are going to have to distribute this thing. And then after this, we're going to go over to the next part of the lesson, and that part's even easier than this. Okay? So now if you're thinking, well, this isn't that easy, well, the next one will be easier than this. Whether this is easy or not for you, but it'll be easier than this. So we're going to distribute, okay, so that we can find our solutions. So start off with the green ones. 3d times 6d, that's 18d squared. 3d times negative 1, that's negative 3d. Now go to the blue lines, right? 1 times 6d, that's 6d. And 1 times negative 1 is negative 1. Let's combine some like terms really quick. That's 18d squared. Negative 3d plus 6d is positive 3d minus 1. Now I'm done. I simplified it as much as possible. Now I'm going to look at this. Look at all the variables of d. This has a power of 2. This has a power of 1. They're whole numbers. They're positive. Okay? That means this is a polynomial. So what's my degree for this one? 2, right? Thank you. So degree is 2. What's my leading coefficient? It's 18. Thank you. So there you go. And we're done. Okay? So again, this is simple. It's just they might make you do a little bit of extra work. Okay? But it isn't hard to do. Identify whether or not it's a polynomial. How can I tell? Positive powers, whole numbers as the powers. Now the front can be a fraction. This could have been like 18 over 7, and this could still be my leading coefficient, 18 over 7. That's okay. The powers cannot be fractions. The powers cannot be negatives. Okay? Your variables should not be in the denominator of a fraction. That's what was the problem with that one right there, 2 over x, right? That was the problem. So are we good with this? All right, so that's numbers 5 through 8. Okay, let me give this to you. Numbers 5 through 8 is what that is. Okay, now we're going to move to 9, 10, and 11. And these are pretty easy. Let me define it. Graphs and numbers of solutions. So for the next 3 problems on your homework, they're going to say, okay, look at the picture of this graph. How many zeros does it have? In other words, how many solutions does it have? The way you tell, and we've already learned this, we're actually just kind of revisiting, you can tell how many zeros or solutions or roots a graph has based on how many times it touches which axis, the x or the y? The x, right? So graphs and number of solutions, I'm just going to put right here, count how many times a graph touches the x-axis. This is really simple. They're going to give you pictures, so it's not like they're going to be all like secretive. They're going to give you pictures. So this is what it's going to look like. I'll do like 2 of them, okay? And that's it. I mean, we really don't have to do much more than that. Actually, you know what? Let me change this one a little bit. So if I ask you for this first graph right here, if I were to tell you how many solutions, I'm not asking you what the answers are. I'm saying how many do they have for the first one? Well, you would say 1, 2, 3, 4, 5 solutions. That's 5 because it crosses the x-axis a total of 5 times. What are the answers? I have no idea because I didn't even mark it down or anything. And that's the way your homework is. It's not marked. All they want to know is how many. So 1, 2, 3, 4, 5, 5 solutions for the first one. Okay, so here we go. If I can just circle them just so we can see them. 1, 2, 3, 4, 5. So this one has 5 solutions. Okay, how many solutions does the other one have? Say again. 3. It has 3. It has this one, the one in the middle, and then when it barely touches the x-axis, that's 3. This has 3 solutions, and we're done, okay? So for your homework, this is all we're doing. The 3 last problems you're going to be working on is just look, and if you want, circle where they're at just to make sure you get them all counted, and tell me how many you circled or how many you put a dot on, whatever you want. Tell me how many solutions you have, and then the previous problems, you're just going to tell me, is it a polynomial? If it is, what's the degree? What's the leading coefficient? If it's not a polynomial, tell me why. Why does it not work? Okay, so let me stop the recording. You guys already have the homework.